Hello everybody, this starts our new section on solving rational equations. So 6.3, solving rational equations. And if you want to keep track, it's 6.3, day 1. So we'll have 3 key steps here. First, simplify each side, and then cross multiply. Because now we will be dealing with equations. This will be a tool in the toolbox that we will use to start this off. This next step is key. If each side has a common factor, you may cancel those. Factors out. And this is an important note. Both in the denominator or both in the numerator. I'm going to highlight that. We'll actually see what this means once we start getting into our examples. But this is a key solving strategy that we will implement. And then lastly, because of domain restrictions, or domain restriction, remember, we cannot divide by 0. We must check for extraneous solutions. In our day 1 notes, we'll be covering 2 examples. Here's number 1. 4 divided by x plus 5 divided by 2 equals negative 11 divided by x. So using our prior knowledge of adding, we know that we need to have a common denominator. Here, what will our least common denominator be? And I'm hoping we're all saying 2x. And I would agree with you. So to accomplish that, we're going to take 4x and multiply that by 2 divided by 2. And we'll take 5 halves and multiply that by x divided by x. That will be equal to still negative 11 divided by x. Now that we have our common denominators, 4 times 2 is 8 plus 5x, all divided by 2x, still equal to negative 11 divided by x. So if we look here, simplify each side and then cross multiply. So we have simplified the left side. There was nothing to simplify on the right. Now that we have simplified each side, we have a fraction equals a fraction, we will now cross multiply. So that's going to be 2x times negative 11 equal to x times 8 plus 5x. As of this step, we are now into our quadratics prior knowledge, so please press pause now and distribute, combine like terms, get this set equal to 0, and see what the result will be. So right now I'm just asking that you simplify this to have 0 on one side, everything else combine like terms on the other side. Press pause. So multiplying the left side, we'll get negative 22x equals x times 8 is 8x, x times a 5x is positive 5x squared. It's easiest at this point to get this left side equal to 0, so I will add 22x over to the other side. We get 0 equals 5x squared plus 30x. Taking a step back to observe what we have, this is not a trinomial. We only have two terms. It's a binomial. So this is not factoring when a is 1. This is not factoring when a is not 1. This will involve looking for a GCF. So if I look, 5 and 30 are both divisible by 5, so I can factor out a 5. There are 2 x's here and 1 here, so I can factor out a single x. And let's see what's left when we do that. That will leave behind a single x plus 6. Setting each of these factors equal to 0, we'll have 5x equals 0 and x plus 6 equals 0. That results in x equals 0 as our first possible answer, and x equals negative 6 as our second possible answer. And if you notice, I'm saying possible answer because until we check these, we won't be sure. So taking a look here at our original, let's check. For right now, I'm actually okay when they're this simple. As soon as I say that I'm going to check x equals 0, that very first term is no good. We can't divide by 0. So I don't have to take the check any farther. That is extraneous. So you don't have to keep going. As soon as you see that it doesn't work, it's a no. Now let's check x equals negative 6. So it's going to be 4 divided by negative 6 plus 5 halves equals negative 11 divided by negative 6. Now in terms of domain issues, we have none, because here none of the denominators are 0. If you would like to keep moving forward to check for accuracy, you definitely can do that. To get common denominators, we'll multiply this by 3 divided by 3. So that'll be negative 4/6 plus 15/6 equals a positive 11/6, since negative divided by negative is positive. Combining my terms here on the left, we do get left equals right. Moving on to number 2. We have 4x plus 1 divided by x plus 1 equals 12 divided by x squared minus 1 plus 3. Keeping track of the sides of the equation is very important, so we will keep this line going down the equal sign. And our first task is to simplify each side. On the left side, there's really nothing I can simplify here. There's no factor that can be factored out. There's no common terms here that can be factored out. On the right side, we can do some work. So we want to simplify this side to a single fraction. That means that for us here, what will our least common denominator be? It is going to be x squared minus 1. So for right now, we will leave the left side alone. 4x plus 1 divided by x plus 1 will stay. 12 divided by x squared minus 1 will also stay. But now we will multiply 3 times x squared minus 1 divided by x squared minus 1. So now we have 4x plus 1 divided by x plus 1 equals 12 plus 3x squared minus 3, all divided by x squared minus 1. Now technically we could start cross-multiplying because that is our standard next step. We might first consider 3x squared simplify, combine like terms, 12 minus 3. So that becomes 4x plus 1 over x plus 1 equals 3x squared plus 9. Factoring out of 3 won't really help us out at this point. But can we work with this? When I look at these denominators, this is where we're going to get into that highlighted note that I had mentioned was really important. We said if each side has a common factor, you may cancel those factors out, but both have to be in the denominator or both in the numerator. So what that means is, for example, right here, I have x squared minus 1. I can get x squared minus 1 in this side too if I multiply by x minus 1. So watch what happens here. Now I've got x squared minus 1 and x squared minus 1, so these cancel out. We're basically saying if the denominators are equal, then the numerators have to be equal as well, which means x minus 1 times 4x plus 1 has to equal 3x squared plus 9. So let me say that one more time. We're able to horizontally cancel the denominators because what we're really saying is that if these denominators are equal, here's x squared minus 1, here's x squared minus 1, if the denominators are equal, then by the properties of equality, the numerators have to be equal as well. What's nice about this is that we're actually no longer dealing with a rational function, we're back into quadratics. So just like before, please press pause, and I'm asking that we simplify. So multiply this out, get the one side equal to 0, factor, and I'm going to let you take this all the way to the end. So press pause now and work it all the way through, and we'll see if our answers match. So let's see if we match. X times 4x gets me 4x squared. X times a positive 1 is plus x. Sending in the negative 1 here in the denominator, in the bottom, we get minus 4x plus 1 equals, and 3x squared plus 9 is still here. It seems pretty easier to me to simultaneously combine like terms and move these two terms over. So we will get x squared, positive x minus 4x is minus 3x, positive 1 minus 9 is minus 8. And I think I made a sign error. I did. Right here this should have been a minus 1, which makes this minus 10. Equals 0. Now that the quadratic is set equal to 0, we can factor. So a is 1, looking for factors of negative 10 that add to a negative 3. We should have here x minus 5, x plus 2 equals 0. Setting each factor equal to 0 results in x equals 5 and x equals negative 2. Hoping we match on that one. The key learning for this example is what we did right here. So we want to put in a little note, common factors, in the denominator canceled out. Just put a little highlighter there. I would highlight this note to make it stand out. That technically concludes our first day of notes. So I'll put my little done mark. But I would like to show you a preview of what's coming up for day 2 notes. So I will put this one here. So 3 will be 1 divided by 2x minus 1 divided by x plus 1 equals 1 divided by 3x squared plus 3x. So I'll leave that one set up for the next class, and we will have a situation of common factors. So we'll see how we do with that. If you want to give it a try in advance, we should be getting x equals 1/3 as an answer. So if you'd like to challenge yourself to work on number 3 before we do it in class, that would be awesome. Otherwise, start taking a look at the day 1 and 2 homework worksheet and see which of those questions looks similar to numbers 1 and 2 here in the notes. And we will continue with these solving examples in the next class. Have a great day as always. Any questions, please send me a reminder.